All right, welcome back, trig students. This is week 2 of distance learning. I appreciate you guys taking the time to watch this video and join us in this journey and further your education. Let's get right to it. I want to go over some problems that you're going to have this week. You're going to see this assignment on Delta Math, inverse trig common angles, inverse trig functions, and radian trig equations. I'm going to focus on these first two in this first video, okay? I think you should work on these in the first part of the week, and then these, I think there's 10 questions to these, in the latter part of the week, and in that order, okay? Alright, so one of the first set of directions you'll see, something like this. Okay, find all angles from 0 to 360, not including 360, but including 0, that solve the following equation. Alright, so where have we been with this? Well, last week we were reviewing evaluating trig functions, something like this. You'd have sine of 60 degrees, and then you were expected to evaluate that and get this answer, right? The exact value. Okay, now we're kind of flipping the switch, and that's where we're kind of using some of those inverse trig concepts we did in section 4.7 before our shutdown. Now we're going to have something like this. We're looking for the angle that gives us this exact value of square root of 3 over 2. All right, and sometimes there's going to be multiple angles. We'll talk about that here in just a moment, but just kind of a quick little intro of where we've been and where we're going for these trig equations. Okay, so we need to find this angle that gives us this exact value. Let's start by figuring out where tangent is positive. Okay, so where is tangent positive is the question we want to start with, right? So using our rule of sines, we should be able to narrow this down. Tangent is positive in the first quadrant where all are positive, and it's also positive in the third quadrant where only tangent is positive. Okay? All right, so let's start with the first quadrant. Let's create a little reference triangle, kind of work backwards to figure out which angle is going to give us square root of 3 over 3. Now, we don't know the exact angle, so this doesn't need to be drawn to scale. Just place it somewhere in the first quadrant, and let's start working with our common angles. Notice this says over here, common angles. So this reference angle is going to be either 30, 60, or 45 degrees. And by the way, some problems too might be like a 0 or undefined or -1. Then you might want to look at multiples of 90 degrees, right? The unit circle approach. Okay, I'm not going to cover that, but that's how you take that out. Okay, so how do we get square root of 3? That comes from the 30, 60, 90 triangle. So just kind of play with these legs. Maybe 1 is here and square root of 3 is here, or vice versa. Let's start with 1 here, square root of 3, and the hypotenuse is always 2. And then let's just check to see if it works for tangent. Opposite over adjacent. So, of this angle, opposite side is 1 over the adjacent side, square root of 3. To get the square root of 3 out of the radical, we should rationalize this to get square root of 3 over 3. Okay, bingo, we got it. All right, so what angle must be across from 1? It's got to be 30 degrees. Okay, that's something we can always count on. Opposite 1 is 30, opposite square root of 3 is always going to be 60. All right, so there's one of our answers. They actually want us to keep in degrees. We don't have to convert this to radians this time. So we're going to say theta is 30 degrees. But there's a second angle. Where at? Third quadrant. So if we rotate this around to the third quadrant, create a 30-degree reference angle. I mean, I kind of have enough now to already answer it. Some of you guys already probably are figuring out the answer. But I could justify it the same way. I could put 1 opposite this, because that's always the relationship. 2 hypotenuse, this is square root of 3. Since I'm in the third quadrant, this is negative x and this is negative y. All right, so when I take the tangent of this reference triangle now, what do I get? -1 over negative square root of 3, right? Which is going to give me the same thing I had here, because a negative divided by negative is positive. So what is this angle? It traveled around 180 degrees plus an additional 30 degrees. So we need to do that math and do the 180 plus the 30, okay, to get our answer. So it's 210 degrees. So there's the answer two answers to this problem. Okay, so let's go ahead and show you how to put multiple answers over here on Delta Math. So I want to put in 30, and then if you click this plus sign right here, it gives you a chance to put in multiple angles. Okay, so I think there's a third answer or fourth answer. I just keep going. I want to take them away, take them away. Okay, and now here I've got 210, submit answer, and then we're good to go. All right, I should confirm it and all that stuff. All right, okay, I think we're good on that problem now. Oops, let's move on to this next problem. This is going to be from this next set, inverse trig functions, but now they might not be common angles. All right, so this set of problems are going to look like this. Cosine theta, negative square root of 42 over 8. We still have the same restrictions on theta as you see, 0 to 360. All right, and it says to the nearest tenth of a degree. So we're going to end up punching this in our calculator in a moment. I think you should just use your own if you have your graphing calculator. If not, I'll show you how to work this guy up here to the right, okay? All right, we're going to start off the same way. We still want to figure out where is cosine of an angle, oops, negative. Where is it less than 0? Okay? A smart trig class. Cosine is positive in the first quadrant and the fourth quadrant, right? And that's negative. So it can't be where they're all positive. It can't be where cosine's positive. All right, the other possibilities are here. Okay, so our angles that we're going to find now are going to be in the second quadrant and third quadrant. Okay? All right, so obviously this is not from one of our special right triangles. This is where we're going to have to use our calculator. Okay, and this is kind of where I was talking about. We're going to use some inverse trig concepts. If we have the right side and we're looking for the angle, we can use our calculator by doing this. Theta will be equal to inverse cosine of that value, just like this. It's a calculator stroke. Okay. Now remember, inverse cosine was restricted to 0 to pi in our section 4.7. So the calculator is actually going to give me an answer between 0 and pi, but we still need to apply it to this. I'll show you what I mean. Let's go ahead and punch this in. I'll show you two different ways. Here's our calculator here, inverse cosine in parentheses, put the ratio in there, and it gives me 144.1 degrees. Make sure you're in degrees mode, right? Degrees mode, because that's what the directions say over here, okay, of a degree. All right, so I should say 0 to 180 to not confuse you, 180 degrees. All right, so the answer is 144.1 degrees. Okay. Before I move on, let me show you also how you can use this calculator on this. All right, when you want to submit your answer, of course, we have this calculator down here. But if you actually want to use it for a calculator, don't use this. Here's what I mean by that. I'm going to close this, go up to this top right calculator, and I know I'm in the calculator mode because it gives me answers right here. Okay, so you got to be able to go there, and then when you're done, you just kind of X back out. So here's how we do inverse cosine. I don't see it here. You got to hit this functions tab. Okay, so hit this functions tab. I'm going to hit inverse cosine, and then I need negative square root of 42 over 8. So I go back and do negative square root 42. I need to hit to the right arrow to divide by 8 now, and then I get my answer. Okay, and I didn't have to enter. It's already right here, 144.1 degrees. Okay. All right, so theta is 144.1. I have to pause here because I'm running on my time limit. So let me stop the video here and continue it on this next one here.